Hello, I'm Harim Jung. I majored in optics and photonics at Yonsei University. Let me start paper review presentation. The topic is mid-infrared laser technology. The titles of papers are fiber lasers, the 2 micrometer market heat-up, and review of thulium and holmium materials, spectroscopy, and lasers. In fiber lasers doped with one of several rare ions serve as the laser gain medium. Commonly, this active fiber core sits at the center of a double-clad fiber architecture consisting of an outer glass or polymer coating, an inner cladding or pump core, which acts as a waveguide for pump light. This fiber geometry allows the lasers to be easily coupled to high-power, commercially able multimode diode lasers. Fiber laser can operate in CW or pulsed mode. Pulsing can be accomplished by passive or active mode locking or Q switching. In the 2 micrometer wavelength area, mode-locked thulium-holmium-based fiber lasers have achieved pulse width approaching 100 femtoseconds, and Q-switched fiber lasers have achieved pulse width in the tens of nanoseconds. The rarest element used to dope the active fiber core and the energy level transition of those rarest cations determines the wavelengths of fiber laser operation. Ytterbium doping offers the highest output power among fiber-based lasers. Commercial ytterbium laser units can deliver more than 100 kilowatts of CW power at 1 micrometer from a single optical fiber port. Erbium doped fiber lasers, owing to the fluence transition of the erbium cation, can provide output at both 1.55 micrometer and 2.9 micrometer. Thulium and holmium doped fiber laser operate in 2 micrometer wavelength area. The highest CW output power from a single thulium doped fiber laser demonstrated thus far is about 1 kilowatt, the second highest power among fiber lasers. This is power scaling of several fiber-based lasers at different wavelengths, showing the exponential growth in output power over the past 2 decades. Still, holmium laser and thulium lasers are lower in power than ytterbium laser, but it is increasing rapidly. Many industrial sectors have used lasers to process plastic materials for decades. For example, carbon dioxide laser for cutting, diode lasers for welding, and solid state and fiber lasers for marking. But these processes need absorbent materials to the plastic to allow for laser processing. Because plastic materials are transparent from near ultraviolet to near infrared, so these processing are not efficient. But a 2 micrometer laser experience moderate absorption by plastic material. So thulium and holmium doped fiber lasers are ideal for plastic material processing. High average power CW 2 micrometer fiber lasers are an ideal tool for laser welding of transparent plastic without the requirement of any added absorbent material. High peak power pulsed 2 micrometer fiber laser such as Q-switched and thulium doped fiber lasers can remove materials with much less carbonization or color change. This graph is average output power and relevant absorption bands in selected media for fiber lasers at different wavelengths based on selected layers dopant. 2 micrometer laser can be used to LiDAR mapping of greenhouse gases. One of the most important greenhouse gas species in the atmosphere is carbon dioxide. And 2 micrometer laser can detect carbon dioxide because carbon dioxide has absorption line at 2.05 micrometer. Thulium and holmium ions doped in glass fiber media exhibit wide gain bandwidth, covering from 1.7 micrometer to 2.1 micrometer. The wide gain bandwidth means that thulium and holmium doped fiber lasers can deliver femtosecond frequency combs when operated in a mode locking laser. Because in mode locking laser, the wider the wavelength bandwidth, the more wavelengths can be combined, resulting in shorter pulses. From the first demonstration of stimulated emission in thulium and holmium materials in the early 1960s to the subsequent research that followed eventually led to the first eye-safe current LiDAR in 1991 by S.W. Henderson, C.P. Hale, J.R. Margi, M.J. Kabaya, and A.V. Huffaker. This LiDAR system was based on diode-pumped thulium holmium 약 at 2.1 micrometer. The thulium holmium technology reached impressive performance levels in 2006 when researchers at NASA Langley Research Center produced 1 joule per pulse at 2.06 micrometer. Fiber optic lasers can widely used in a variety of applications ranging from material processing and medical applications to free space optical communication, fiber detection, precise frequency metrology, 3D LiDAR, and high energy laser weapons. And this trend is expected to continue in the future. Currently, 1 micrometer lasers are widely used, but 2 micrometer lasers will be used in many industries in the future if obstacles are removed. For example, gallium aluminum arsenide diodes are generally used for 2 micrometer fiber lasers. However, it is not as efficient or reliable as indium gallium arsenide diode pumping ytterbium doped fiber lasers at 1 micrometer. I referred fiber lasers the 2 micrometer market heat-up and review of thulium and holmium materials, spectroscopy and lasers, and internet. Thank you for watching my presentation.